Good morning, ladies and gentlemen. I'm back from Mexico. I'm out of my garage right now. As you can see, I've created this little not tripod, but this little stand that holds my phone. So I'm now at my kitchen table and I'm going to attempt to do some math, not using the whiteboard, but to actually write it out on paper. And we'll see how that goes. So hopefully you were successful last day using the SOHCAHTOA, figuring out which of the three ratios, the sine, cosine, or tangent ratios that you needed to use. Once again, if there's any questions, please don't hesitate to contact me, email me, PM me, or DM me, or whatever the word is, over Edsby. Some of you have done that already, and I'll get back to you. Today we're going to just nothing new. We're going to use the ratios that we've already learned how to use and just apply them to a few, I guess, real world word problems. So let's give this a go, and I'll try to zoom in here a little bit so you can see my paper a little bit easier. So this is 7.5 and just trig involving some right angles. All right, first of all, you're going to come across in the textbook two different terminologies. The first is the angle of elevation. And if you can imagine yourself standing right here, if you are looking straight out, that is the horizon or the horizontal. And if you are looking up, this becomes your line of sight. So perhaps you're looking at a kite or an airplane or a bird in the sky. That's your line of sight. And this degree right here is the angle of elevation. So when we're talking about the angle of elevation, we're talking about the angle above the horizon following your line of sight. And similarly, we have the angle of depression. And so once again, if I'm standing here, this is the horizontal. And if I'm looking down at the ground or down a hill at something, so this becomes my line of sight. This angle here from the horizontal is the angle of depression. So that's the terminology or the two concepts that we have to understand for today's word problems. So I'm going to whip through two questions with you. The first question here is, I just don't know if you can see that. A lighthouse is sitting on a cliff. The top of the lighthouse is 33 meters above sea level. The angle of depression to see a fishing boat is 24 degrees. How far from the base is the cliff of the boat? So let's give this a go. First of all, the first thing we should do is draw a diagram so we can picture this. And of course, this is right angle trigonometry. So at the sort of our, what we want to do here is make sure that we are somehow drawing out a right angle triangle that we can apply trigonometry to. So I'm going to draw a cliff here, and I have a lighthouse on top of the cliff. It's a pretty bad lighthouse. And we know we have some water, and we know we have a fishing boat. So the question mentions that the lighthouse sits on top of the cliff, and the top of the lighthouse is 33 meters above sea level. So from sea level up to the top of the lighthouse here is 33 meters. We also know that the angle of depression to see the fishing boat is 24 meters. So that's assuming you're at the top of the lighthouse here and you're looking down at the fishing boat is an angle of depression of 24. So here's our horizontal. And we know that if we're looking down at it, we have an angle of depression here of 24 degrees. Now, just a reminder from grade 9, when we had our some angle rules. When we had two parallel lines and a transversal, we know that if this angle is 24 degrees, this angle here, the alternate angle is 24 as well. So we know we have that the horizontal and the C are parallel. Our line of sight here becomes the transversal. So if this is 24, this is 24 degrees as well. I suppose we could have figured that out a couple other ways. This is 90 degrees here. This is a complementary 90-degree angle, so we could have figured this angle out as well. And using our 180 rule, 180 minus this would give us 24 as well. So a couple different ways to figure it out. But anyways, hopefully now you can see that we have a right angle triangle. And so to solve this, I'm going to use tan. If I also label up our triangle, our line of sight becomes a hypotenuse. The cliff and the lighthouse is our opposite side. And the water is our adjacent side. So we are trying to figure out how far we are here from the base of the cliff. We want to find out the adjacent side. And since we have opposite, we're going to use opposite of adjacent, and that is a tan function. So we have tan 24, or tan theta, 24 degrees is the angle that we're using, equals the opposite over the adjacent, tan 24, the opposite side is 33 over the adjacent, cross multiply, a tan 24 is equal to 33. I want to get a, the adjacent side, on its own. So I'm going to divide through both sides by tan 24. These cross each other out. We get a is equal to 33 over tan 24. 33 over tan 24 is 0.4452. And when we divide those up, we get 74.12 meters. So we know that from the base of the cliff out to the fishing boat, it's 74.12 meters. A big reminder from last day is make sure your calculator is in degree mode for this to work. All right, hopefully you understand that question. And moving on to a second question here. So from the window of a building, the angle of elevation to the top of a second building is 41 degrees, and the angle of depression to the bottom of that building is 54 degrees. The buildings are 54 meters apart. What is the height of the second building? So once again, let's draw this up. So we have building 1. And we have building 2. And we want to know the height of building 2. So this mentions that from a window here, if we're looking out the window, straight across would be the horizontal, of course. And in this case, it says our angle of elevation to the top of the second building is 41 degrees. So we know along our line of sight here to the top of the second building, we have 41 degrees. And I'm assuming these are not the Leaning Tower of Pisa, and that they were built at a right angle to the ground. So our line of sight also forms a right angle with the building. And to the bottom of the second building from the same window, we have an angle of depression of 54 degrees. So we need to find the height of this building. And what we're going to do is we're going to treat it as two questions. We are going to ignore this triangle and just work on the top one and find this height. And then we'll do the same for the bottom triangle. We'll just figure out this, add the two together, and we have the height of building number 2. So let's start with the top one first. Labeling our 3 sides to this triangle, this would be our hypotenuse, this would be our opposite, and this would be our adjacent side. Now, we do know that the buildings are 56 meters apart. So from here to here is 56 meters. So once again, because I'm dealing with an O, which is what I want to find the length of, and I have A, O and A, that's going to be a tan function. So we'll do tan theta is equal to opposite over adjacent. We know what theta is. It's tan 41 is equal to the opposite, and we know the adjacent side is 56 meters. Cross multiplying, we get 56 times tan 41 is equal to the opposite side. And when we run that through our calculators, we get 49. So that tells us that this dimension right here is 49 meters tall. So we now have 1/2 of the building's height, or not necessarily half, but we have half of our calculations done. Next thing I'm going to do is try to find out this. So just dealing with our bottom triangle, once again, this is going to be the opposite side. This will be the hypotenuse, and we have the adjacent. And since we're using adjacent and opposite again, it's going to be another tan function. So this was for the top of the building, and now for the bottom, we have tan theta is opposite over adjacent. Tan 54, that's our angle here, our angle of depression. We don't know what the opposite is, so we'll just keep it as O. We do know the adjacent is 56. Cross multiplying, we get 56 times tan 54 is equal to the opposite. And when we put that into our calculators, we get 77 meters. So the height of building number 2 would be 49 meters plus 77 meters, and we get 126 meters tall. There's the height of our building. So I will post for you the homework, pictures of that, the answers. Once again, if you have any difficulty, please don't hesitate to contact me or contact a class member who can help you in real time work through it. This is not difficult. With these word problems, draw your diagram. Of course, in both cases here, we tried to make it resemble a right angle triangle, so then we could use our trigonometric functions. All right, ladies and gentlemen, have a good day.